Hey class, this is AP problem number 1. This is the first time that you're seeing basically a free response problem from one of the previous tests. So let's take a quick look at this. I'm going to do just part A. I'm going to do each of these screencasts in parts so that you only have to watch one small part instead of watching the whole thing. You can watch like different parts then and even go back and watch only one other part then if you're not getting it. Okay, good. So this says Cl2 gas can be generated in a laboratory by reacting potassium permanganate with an acidified solution of sodium chloride. The net ionic equation for the reaction is given above. Net ionic equation gets rid of all of those things that don't matter that are spectator ions. So notice that when you look at this part right here, you see that that is that instead of that. So NaCl is what was added, but we're only concerned about the Cl minus. Okay, good. So let's keep going. Oh boy, there we go. And take a look at the problem. So a 25 milliliter sample of 0.25 molar NaCl reacts completely with excess of KMnO4. The Cl2 produced is dried and stored in a sealed container. At 22 degrees Celsius, the pressure of Cl2 in the container is 0.95 atm for atmospheres. So, okay. Now, this is not a chapter 14 problem in the beginning, not A. Part A is not. Part A is part of chapter, well, let's see, that would be chapter 4 and chapter 3. For stoichiometry, the calculations with equations, and molarity is chapter 4, I believe. So let's do just like a quick review for I. So we're going to calculate the number of moles of Cl. This is actually not too bad because here's what we know. We know that 1 mole of NaCl is equal to 1 mole of Cl minus. And the reason why we know that is that this subscript for Cl in NaCl is a 1. So it's a 1-to-1 ratio. If it were something like NaCl2, it would be a 1-to-2 ratio for the number of moles of NaCl2 to 1 mole of Cl minus. So because there is no subscript there, then I know that if I'm finding the number of moles of NaCl, I'm also finding the number of moles of Cl minus. So how do I find the number of moles from the information that's given? Here I have a volume and here I have a concentration. Now, here's what we know. We know that concentration is the number of moles per liter, and my volume here is in milliliters. So I got 25 milliliters, and I need to change that to liters. So I go 1, 2, 3 places to the left, and what I end up with then is this number of liters. So now I can solve my problem for the number of moles because I have the number of liters and I have the concentration. So here's what that looks like. Moles equals M times V, which equals 0.25 capital M, and then this is 0.02500 liters, like that. Okay, so whatever the calculation is, and that calculation ends up being 0.00625 moles, and that's the Cl minus. Excellent. So that's the first part. So part 1 there is, or I, is 6.25 times 10 to the 20 to the minus third. Now let's take a look at calculating the moles and the volume in liters of another part of this. Now, here's what I got. As you can see, I have 2 different pieces of an equation. The one piece of the equation is this, that's where we started, and then that goes to 2Cl2 on the other side. So I have 4 moles of chloride reacting to form 2 moles of chlorine. So changing the moles of chloride, there we go, over 1 times, where are we at here? 2 moles of chlorine gas divided by 4 moles of chloride like this. Oop, I should put the moles in there first, like that. And then whatever that is obviously this number divided by, so 0.003125 moles of chlorine. That's it. Okay, that's the number of moles of chlorine. And now we have some other things. We have a temperature and we have a pressure. So in chapter 10, the most useful equation that we use is the ideal gas law. The ideal gas law says PV equals nRT. Okay, if we're solving for volume, then I divide both sides by P like this. Volume equals nRT divided by P. Now there's a couple things that we need to realize here. Number one, our R value has to match our pressure, and our pressure is in atmospheres. Our temperature must be in Kelvin. So let's see. If I'm listing the stuff that I have this for the number of moles of Cl2. I have my R value, since it's what is that point? Where are my R values at? 0.821. That is liters atmospheres over mole Kelvin. There we go. Good. That's my R value. My T is 22 degrees Celsius, which equals, if I add that to 273, that equals my Kelvin, which is 295 Kelvin. Okay, and then my pressure is 0.95 atmospheres. Excellent. So now all I have to do is plug that stuff all in, give me a little bit more room so that my volume equals, so that's going to be 0.003125, 0.0821, and 290, that's a 5. That's an awful 5. K, like that. And then we're dividing all of that by 0.95. Excellent. So at the end here, after the calculation, I get 0.0797 when I round off to liters. And that is the answer to I2. And that's it for part A. Stay tuned for part B, C, and D.